Okay, welcome back. So what you're going to see here with C is a little bit more of a complicated type of equation, but the ideas that we're looking at here is still the same, right? We're still trying to get to a point where we want to equate the exponents to make the equation possible to solve, and we can only do that by trying to express everything under a single power with the same base. Okay, if you can't express under a single power with the same base, then right now we actually won't be able to solve it. That'll be more of a grade 12 problem because it involves using logarithms and stuff that you haven't seen yet. So right now we're only trying to solve things by trying to express things with the same base. So if I see 25, 625, and 125, I should be able to at this point to recognize all these as being powers of 5. So I'm going to rewrite 25 as 5 squared. So I get 5 squared to 3x minus 2. I'm going to rewrite 625 as 5 to the exponent 4. So I have 1 over 5 to the 4. I'll deal with the 1 over part next. Okay, and then, of course, 525 is 5 cubed. Okay, so that's the key first step there, trying to get everything at least underneath the same base, and then try and simplify as much as you can. So here, with the green ones over here, I'm going to do power over power again, so I'm going to get 5 to the 6x minus 4. Okay, 1 over 5 to the 4 is the same thing as 5 to the negative 4. Okay, so simplify that in my next line. And here, I'm going to wind up with 5 multiplying the 3 into here. I get 12x minus 9 all over 2. And that 3 multiplies in the numerator there. So I get 12x minus 9 all over 2. Okay, so just take one line here to simplify here. So I still have 5 to the 6x minus 4. Okay, don't forget your brackets here. And I have 5. This is going to give me 8x minus 4. Okay, and even though everything's under a same base here, I still cannot equate the exponents. The reason why I can't equate the exponents yet is because I don't have a single power on each side. I only have one power on the right side, this 5 to the 12x minus 9 over 2. But over here on the left side, I still have 2 powers of 5. So before I can start equating the exponents, I have to be able to combine these together as 1. So to put them together, I'm multiplying them together, so I'm going to add the exponents. So I'm going to wind up with, once I do that, 5, and so I'm going to add the exponent. 6x plus 8x equals 14x, and negative 4 minus 4 gives me minus 8. So I get 14x, 5 to the exponent, 14x minus 8 equals 5, and I have all this mess over here, 12x minus 9 all over 2. Okay, now it's a single power on each side. It's the same base of 5, so I can equate the exponents. And again, it's when you get to this point that you become a lot happier, because what you have to solve now is a little bit easier. Okay, so I'm going to multiply, I'll let you finish this up on your own here, but you're just going to multiply both sides of the equation by 2. So you're going to get 28x minus 16. Okay, and that should give you 7 over 16. Which is the same thing I got up there. Okay, so again, same idea, single power, same base, each side of the equation. Equate the exponents, and then you can solve. Okay, for this next one here, you'll notice here take a quick look at it here. You're going to have some trouble getting everything under the same base here, because there's this 27 here, which, right now you see a lot of powers with base 3 here. And in theory, you could express 9 as a base 3, you could express 27 as a base 3. You can't express 244 as a base 3. Okay, so at this point, no matter what you actually try and do, with all this addition and subtraction going on here, you will not be able to put these all under a same base. So there has to be another trick here, and there is. So what I'm going to do here, I'm going to rewrite this, and instead of 3 to the 2x, I'm going to rewrite this as 3 to the exponent x all all squared. Okay, I'm going to keep the rest of the equation the same, and I'll talk about why I did this in a sec. Okay, so first off, hopefully we can agree that I didn't do anything illegal here. So 3 to the exponent 2x is 3 to the x squared, because what I would do here if I want to simplify this is multiply the exponents together. So I'd have x times 2, which was 2x. So I'm just rewriting this in a different way, because what I'm trying to get at here is if, for example, instead of 3 to the x, we just had another variable here. So let's just say instead of 3 to the x, I replace it with another variable I'm just going to call, let's say, k. So if I let k be equal to 3 to the x, because really those 3 to the x's are making this equation a bit more complicated, what am I going to wind up with here? So I'm going to wind up with 27. Instead of 3 to the x all squared, I'm going to have k squared. I'm going to have 244, and again, instead of 3 to the x, I'm going to have k, and I have plus 9. Okay, so after doing that little substitution here, replacing 3 to the x with k, what's left over here actually looks like a nice little quadratic that I can, in theory, factor or use quadratic formula on. Okay, so by replacing 3 to the x, this becomes a lot simpler to work with, and I know that it seems like, I don't want to say wizardry, but something a little weird, because I didn't like the 3 to the x's here, so I just kind of replaced them with another variable. And, you know, yes, we are allowed to do that. We'll have to deal with the fact that we made a substitution later on in the equation, but for now at least we made the equation much, in theory, simpler to solve. Okay, so to solve for this one, I can actually factor this one. If you check the discriminant of this, the discriminant is a perfect square. So it does factor. If you're having trouble doing the factoring, feel free to use quadratic formula for this to try and get your answers. So I'm going to have, after looking for a common factor here, of which there isn't any, I'm going to put 27k squared here, and 9 down here, and I'm going to try and factor. So let you try and factor through this one on your own. But the array that does work here is having 27k minus 1 and k minus 9. Okay, so I end up with minus 243k here and minus 1k here to get the minus 244k that was in the middle. And again, in no way was this necessarily an easy one to factor, so again, if you find quadratic formula a little bit easier to use in this circumstance, please feel free to do so. Okay. Either way, you're going to wind up solving for k in the end. So I'm using factored form here, so I'm going to have, for my next line, k minus 9 and 27k minus 1. Okay, remember this is all going to be equal to 0. So remembering how I would solve a quadratic here, I mean, it means I have two factors here. So it tells me that k equals 9. And I also wind up with a situation where I have 27k minus 1 equals 0. Okay, so if I solve that one here, I move the 1 over, divide by 27, so k is equal to 1 over 27. Okay, now I'm not done. Okay, I've solved for k, but now we got to go back to our original equation here. Remember that originally we let k be equal to 3 to the x. So at this point now, this is where this comes back into play. So in each of these equations, I need to replace the k value with 3 to the x, and actually then solve for x. So for the one on the left here, it's not too bad. I wind up with 3 to the x equals 9. Okay, so what power of x equals 9? Well, this was an atypical exponential equation. I'd write both sides under the same power. So 3 to the exponent x, 9 is 3 squared. So I wind up with x equals 2. Okay, so that solves that particular factor. Now I have to see what happens with the other factor as well. So again, looking at this one, I'm just going to continue it down here. If I replace k with 3 to the x, I get 3 to the x equals 1 over 27. And just like before, I need to express both sides under a single power with the same base. So 27 is 3 cubed. And since it's 1 over 3 cubed, it's the same thing as 3 to the negative 3. So that tells me now that I can equate the exponents, x equals negative 3. Okay, so a lot goes into this, but again, what made our life easier at the start was doing a substitution, replacing our exponent terms, or our powers, with a certain variable, factoring that expression, then once we finish solving, putting the 3 to the x back in and solving for x. Okay, a lot goes into it, but once you've seen a few of these, they tend to all work in a very similar pattern. Okay, last one. I'd like you guys to try this one on your own first, okay, and push play when you're ready to go through the answer together. Alright, so you can take a look and check your answer here. You should have gotten 2 over 3 and 4 for your answers. So I looked at two somewhat similar but a little bit different methods of going about the algebra for this one. So looking at method 1 here, the way you probably would have approached, at least I think so anyways, is to try and express everything under the same base. So if you look at 4, you can express 4 as a power of 2 because 4 is 2 squared. And you can actually express 1 as a power of 2 as well, because anything, absolutely anything to the exponent 0 is 1. So you can write the right side of the equation as 2 to the exponent 0. Now, once I did that, I have everything with powers of 2, just got to simplify it, so I have a single power. So I wind up leaving the numerator alone, using power of a power here with the denominator, so 2 times 5x minus 4 gives me 10x minus 8. So I wind up at this step here. And again, still need a single power, so I have two powers of 2. I'm going to subtract the exponents, so I wind up with 2 to the exponent of 3x squared minus 4x minus the exponent of 10x minus 8. And then I just simplified inside there, so I got 3x squared minus 14x plus 8. So I have a single power on both sides of the equation. I can equate the two exponents to each other, so I wind up with 3x squared minus 14x plus 8 equals 0. And by now I know we're all experts at solving quadratic equations, so you can either factor or use quadratic formula. This one factors into 3x minus 2, x minus 4, so I end up with x values, or solutions of 2 over 3 and 4. Okay, so that method works. One way you might have also approached it as well is instead of expressing the right side as 2 to the exponent 0, you could have multiplied both sides of the equation by 4 to the x minus 4, or sorry, 4 to the exponent 5x minus 4, because multiplying by 1 doesn't actually change anything. So right off the bat, I wind up with something that looks like this. Okay, and then I can do exactly what I did with the denominator over here, is express 4 as 2 squared, and use power of power to simplify that into 2 to the exponent of 10x minus 8. So right from that point, I now have a single power on both sides. I can equate the exponents, so I get 3x squared minus 4x equals 10x minus 8. And even though it's not already equal to 0, it's still a quadratic equation, so I know I have to get everything over equal to 0 on one side. So once I do that, I wind up down at this second last step down here. So I then factor and then get my x-intercepts, or sorry, my solutions in this case. So a couple different approaches here. Both will get to the same place, just a matter of what you find easier. Okay, so just remember that big important thing with exponential equations. In order to equate the exponents, you need a single power on both sides of the equation, and that power has to be of the same base. Okay, so that's it. All your homework's from a worksheet that I've given you guys, and please, again, do practice. Lots of different types of problems you might run into, so try and do as many different kinds, and there's less I can trick you with down the road. All right, cheers.